Okay, this video is for Unit 3B. It's quadratic applications, and this is our test review. This is intended to be one for you to do on your own as a practice test, but I thought I would make the video in case you wanted to go through, have questions on a problem. You can always fast forward the video to the question you have, or you can just watch the whole thing and get a big overview. All right, this is a long review. I do feel like if you do all of the items or watch the video all the way through, I think you'll be well prepared for the test. The test will be shorter in number than this actual review. This has a lot of items on it, and I want to be sure you have a chance to finish in one sitting. All right, number one, planners of a Broadway musical. This is the kind of problem where we would actually need to use our calculator. This is the income and cost problem, and we've done a few of these in class. So the first thing we do is we'd go to y equals, and I'm going to clear out these stuff I have, and I'm going to type in exactly the way I see it. And obviously I'm going to have to use an x for p. All right, and then I'm going to use my table. So the thing that you want to do is you want to go second. I'm going to go table set, see where I'm starting. I want to start at 0, and I want to change it by ones because I had previously done something. So now when I look at my table, what this says to me is if I charge $0 for a ticket and X, then I'm going to have 0Y, which is income. If I charge $1 X ticket price, then I'm going to have $34.80 in Y income. So we need to know that the X's are prices, Y is income. So basically what it says for me to do is I'm looking for the projected income. What is the projected income if the price of the ticket is $10? So if I simply just use my data table and I go down to $10, it seems like the projected income Y is $24,000. So number one is A, $24,000. The next question, again, I'm using the same function, and I did that for the first few because I wanted you just to answer different questions related to the same thing. What is the maximum projected income? The maximum projected income. So that means I'm going to have to go down my Y column until I get to bigger and bigger numbers. So it looks like I'm still getting bigger, 27,000. Uh-oh. I'm going to pause right there because I'm noticing at 15, my projected income is 27,000. At 14 and 16, I'm at 26,880. So that tells me my answer is 27,000 is my maximum, and that would be letter D. And then it says, what is the domain of the function? Okay, we need to remember that domain, if I underline that key word, domain of the function is a set of the x's. Okay, in this case, my x's are the same thing as the p price. Remember, I'm using an x in place of p. So basically, that means that it's a set of the possible prices. Okay, if you will recall, okay, I have a possible price in the X column, and I'm going to actually go down until I get to 0 a second time. It's possible to have 26, 27, 29, up 30. It's possible to have 30. It's projected me to have 0 income. If I go to $31, I have negative income. We do not deal with negatives. That's not going to be possible. So we're staying within the possibility. It looks like my ticket prices are between 0 and up to 30. So 0 to 30. And of course, my answer is P price, 0 to 30, letter B is my answer. All right. The planners of the Broadway musical, they also have costs. Notice that this is the same equation. It's the same equation in third, same equation here in the fourth question. They also have costs. So just like what we did in the past, we would actually go to Y2, and we're going to put that in there. It also asks me to sketch. So I'm going to go to Y2 first. And when I go to Y2, I'm going to type in the cost equation. 15,000 minus 50x. Should have been a P, it's a typo, but we got an X in there. All right, I'm going to go back to my, actually I already have my numbers. If I have my window settings, okay, this is where I'm going to pause and I'm going to say check your window settings. Okay, remember we said the price of the ticket is going across the bottom. The price would be between 0 and 30. That was actually the question we answered in number 3. And then in number 2, it asked me the maximum projected, so 0 would be the least amount, and then it said 27,000 would be the highest amount. So what I'm going to do is keep those numbers in mind. Remember, those numbers came from the table. So I'm going to go to my window, and I'm going to change it. Oops, sorry, window, 0 to 30, okay? I'm not going to bother with scale, and from 0 to $27,000, all right? Now, if I hit graph, remember, Ms. Jessup keeps saying, if you can see a perfect graph across your screen, you know you've got the right numbers. And now we actually see the cost line. So if I pick up my pencil and I just simply sketch, okay, and then I see, you know what, there is a cost equation coming through here. That is what we've seen a few times. This is my cost equation. It is a linear graph. This is income equation, and it is my quadratic graph, okay? All right, and we do know that the perfect price, even though it's not required, we're going to talk about it this way. The perfect price between 0 and 30 would have been $15 ticket. And if I go up $15, I would have maxed out at $27,000. So the maximum is actually at $15,27,000. And that's just to make sure we reference. For what price or prices were the income and cost the same? Now the same means, okay, income and cost the same occurs twice. It occurs right here at this intersection point and also over here at this intersection point. So when it talks about cost being the same, I need you to think of intersection. I need to do intersection with my calculator. So grab your calculator, and I hope that you have your calculator. I hope you're doing the buttons with me, because this is going to be meaningful to you if you practice. We're going to put the trace key, so I'm going to tap the trace key. Now I'm going to actually go down, hit the down arrow, because now I want to trace across the other line. Remember, you just have to get closer to one side than the other. I think I'm closer to the left. Second, trace, which is the calc menu, number 5. And then I need to press enter 3 times. 1, 2, 3. My first answer is, that's $4.89, but the 8 is going to round that up to $4.90. So the first answer is $4.90, which would actually be this particular point right here. Now, it says to find 2 points. I'm going to go intersection again. So hit trace. And of course, I'm going to trace the second line. And I have to go a little slower. You can actually hold your button down. It doesn't like it if I go too fast. So I'm going to go to the other side. As long as I'm closer to the other side, it'll find the closest intersection. I think that's probably close enough. Second trace, which is the calc menu, number 5. And I'm going to do enter, enter, enter. My second intersection point is at $25.51. Again, the 8 after the 1 is enough to raise it to 52 cents. $25.52. $25.52. That would be this point right here, $25.52. Okay. All right, so this is an example of what we've done. We did this over 2 days. When income and cost are the same, or at the same at that time, we are not losing money nor making money. We are just what? We are just breaking even. So this is a big review. When the income exceeds the cost, and that word exceeds means more. So when income is more than cost, then you are considered to be making a profit. So in the first 6 items, we have actually reviewed everything we did with income and cost. We've answered, and this is what it could look like with multiple choice, so be prepared for these kind of questions. All right, starting with number 7. A ball is thrown into the air, and its equation in feet. Based on this equation, what is the initial height? What is the initial height? Notice that I do have an equation, and it's just simply asking me, where did I start? When it says initial height, that's the same thing as the start height. And guys and girls, there's nothing to calculate. It's a recognition. These numbers in the equation mean something, okay? This number right here comes from gravity. It's not a number that you have to memorize. It'll usually be provided. But this number right here means something, and this number right here means something. Turns out this last number is your initial height. So the answer to letter number 7 is C, 10 feet. Okay, I did not need to use, I didn't need to know anything else except that the last number gives me height. Number 8, same equation, ball thrown into the air. Based on this one, what is the initial velocity of the ball? The initial velocity is like the start speed. How fast, or the starting velocity. How fast did we throw the ball? Okay, that's also a number in the equation. It turns out it's actually the middle number. So that answer is 40. Again, you have to just know that. I didn't realize until after I had printed everything, but actually number 9 is a repeat of number 8. That was not intentional. So we're just not going to worry about that. It's the entire, it's just a copy by error. Number 10. Now I noticed that we're using the same equation. Okay, same equation that we've been talking about. This time I'm actually going to be asked to find something. In how many seconds does the ball reach its maximum height, round to the nearest hundredth? That means 2 decimal places if necessary. What is the ball's maximum height? Okay. All right. So what I'm going to have to do is I'm going to have to use my calculator. I'm going to go y equals, and I'm going to clear out what I did just a minute ago. Type in this equation, negative 16x squared, because I don't have a t, plus 40x plus the start height of 10. I'm going to actually go to my table. So if I go to my table, okay, I actually want to go back and start my table at 0 and 1 just to get an idea. So it looks like, according to the table, by the time I go 2 seconds, I'm 26. 3 seconds, I'm on the ground. Okay. Now let's just make sure that we remember what we're looking for. We're looking for the what? Maximum height, and in how many seconds, and then what is the maximum height. So I notice that there's 2 answers every single time, a seconds answer and a feet answer. All right, maximum height. So let's go back and look. So it looks like at 1 second I'm up as high as 34. Okay, might go higher than 34, probably does. So this is where I'm going to break my table down. I'm going to go press second, table set. I'm going to say start at 1, and I want you to break the table down by at least 1 decimal. Now let's look at the table. 34, 34. Looks like it gets up to around, what, 34.96? 34.96, somewhere around 1.2. Okay, 1.2, somewhere around 34. Do we have an answer that's really close to that? Okay, this one says 1.25. That's probably right, 1.25. So far I'm liking these numbers. Don't like 2.5, that's too much. I like those numbers. But then when I look at my second table, or my second answer, looks like my answer is really close to 35. 85 is too much. 40 is really too much. 35 is letter D. So I actually didn't even have to go all the way to 2 decimal places, but I could have. I was able to get my answer that way. All right, let's go on to the next one. If an object is dropped from a height of 50, the function gives us the height. Well, if we just take a look at the graphs, remember, we're just dropping this. And we mentioned that if you just drop something, you're just dropping it from a height. That means that it has no initial velocity. Basically, you're just holding it out there. It has 0 speed to begin with. Okay? And again, that's why my equation only has 2 parts. I hope that everybody just kind of glances at the choices and says, you know what? Parabolas that we're talking about, they do not go curved like this. Okay? B and C are possibilities, and I hope that you can see that this one starts at the bottom and goes up to 50. So I hope that actually you can discount A and D immediately. Now I'm actually looking at these. B and C both have the right shape. It kind of goes out and comes down, goes out and comes down. I'm noticing that this one actually, across this one, it looks like it hits the ground right here between 1 second and 2 seconds. And on C, it looks like it hits the ground over here between 3 seconds and what? 4 seconds. So I think if I just simply grab my calculator, type in the function equation, negative 16, okay, we'll change my table set back to 0 and go back to 1. That's just generally where I like to start. Go to y equals and clear. Negative 16x squared plus, this thing is 50 feet in the air. And so now if I just go second table, oh, okay, I think I know my answer. At 1 second, we're 34, and at 2 seconds, I'm negative. Remember, when you go from positive to negative, that means that you have already hit the ground, and that happens between 1 second and 2 seconds, not between 3 seconds and 4 seconds, because at 3 seconds, we're already on the ground. So that means my answer choice for this one should be B. A quick glance at my table, or I do want to mention this, you can kind of take a look at these numbers, and you could actually take a look at the picture. If I go to my window settings, I'm noticing that it goes as high as 50, and we notice that within 2 seconds it's actually on the ground. So window settings. This thing goes as high as 50, because that's where it starts, and my Y is from 0 up to as high as, let's say, what was it? Or excuse me, no, sorry. X is the time, my bad, that's the time. This thing's on the ground within what, a second and a half, so I'll go 3 at the most. And this thing is high as 50. You can actually take a look at the graph, and you can actually confirm, yes, B is the correct answer. Remember, this mark right here is 1. First mark is 1, then 2, then 3. So you can actually take a look at the graph, but you do have to play with your window settings. 12, rocket is launched from a cliff. Initial velocity of 141. Notice that initial velocity of 141 is not in the equation. Is that a V number or is that an H number? Okay, hope you know that's a V number, so that number should go right there. Substitute a 58-foot cliff. 58-foot cliff, that's actually my starting height. Those two numbers should go in the equation. So 141's in the middle, 58's at the end, 141's in the middle, 58's at the end. I know that C and D, or B and D, are out. Now, I do need to see what the second answer is for. It says, which equation is correct, and how long will it take the rocket to do what? How long will it take the rocket to hit the ground? There's a big difference here. It's either 9.2 seconds to hit the ground or 0.4 seconds to hit the ground. I think if I just type this in my calculator pretty fast and look at the table, I'll be able to get my answer. Okay, so clearing out the other thing, and negative 16 t squared plus 141, that's how fast we were going, t, plus we were on a 58-foot cliff, that's my start speed. And if I go back to my table, it looks like I still have a lot of time until I get up to about, between 9 seconds and 10 seconds, I've hit the ground. So that makes my choice pretty easy. 0.4 is way too short of a time, so my answer to this one is A. Okay, again, knowing how to use your table is going to be very important. Ball is thrown upwards from the roof, 80 feet above the ground. Again, look and see where 80 is last because that's my start height. It will reach a maximum vertical height and then fall back to the ground. The height of the ball from the ground at time t is h, which is given by the equation. What is the height of the ball after 3 seconds? It's pretty easy. I'm going to have to look in the table, see if I can find it. Okay, a lot of these is just manipulating your equations or putting them in your thing. We'll change this one to 64, and then it's going to be plus 80. Type over that. I think my equation is now correct. So I'm looking for what is the height of the ball after 3 seconds. And I'm going to remember that in my table, 3 seconds is the x number. So x at 3, my answer for y is 128. Pretty quick, pretty easy. Consult your table, and I think you have it. Okay. D, correct for 13. Number 13, same question. Did I just recopy 13? Okay, it's not twice on your paper, but I have actually, so that's a repeat, and that's just me taking a screenshot. Okay, so you already have 13 answered. We don't need to answer it twice. 14, suppose that we have a V function, and a V, I'm going to assume, stands for what? Value. So the value function says, and we did a few of these in class when we did the little game, the activity. Describes the value of a car from 1960. It says what year did the car have the least value? So I'm going to pay attention. That's actually a minimum. And of course, x equals 0 in 1960. All right. This is a big calculator test. Make sure that you practice 40x squared minus 500x plus 5,000. If I were to ask you the start value, okay, Would you remember that the number at the end is the start amount? And since this equation is for V, this would be the start value. Remember, if it was for H, it would be the start height. So apparently this car was valued at $5,000 when we started. Okay, let's look at the table. And we're looking for the least value. Second table, table. All right, 5,000, 4,500, 41, 38, 36, 35, 34, 34, 60, 30. Okay, start to go back up. It looks like at 6, I'm at 34.40. That is the lowest that it seems that it got to. So the least value would be $3,440, and that would be 6 years. That doesn't answer my question. It says, in what year? So I simply have to say, well, it's 6 years according to the table, but I'd have to remember we started in 1960, so what's 1960 plus 6? That would make it 1966. Choice C is correct. A diver jumps off the platform and her height is given by the function. At what height did she leave the platform? Ooh, I don't think I even need to put this in my calculator. At what height did she leave the platform? How high is the platform? Remember, this would be your start what? This is a H equation, so this is a height equation. So this is my start what? This is my start height. I just need to recognize what I'm looking at. Nothing else, nothing more. 16. In the equation, and this is where if you have your sticky note, this is when we were practicing inside numbers and outside numbers, negatives in front, and so forth. Which part of that function will make the parabola shift up or down? Up or down? I believe that's a number on the outside. I think that's your very first bullet. A number on the outside makes it go up or down, same as the number, because if you're outside the jail, you're probably doing the same thing you should. So the number on the outside is the +4. So the answer to 16 is D. Which equation represents a shift of 3 units to the left? 3 units to the left. Remember, that's your second bullet. That's a number on the inside, but it always goes in, guess what? Inside is always opposite. Now, think about this. If it shifts 3 units to the left, that's -1, -2, -3. You're actually 3 units to the left. You're actually at -3. But when it goes in, it goes opposite of that, so it's going to go in as +3. So I need an inside number that goes in opposite, and it's actually going to go in as +3. So I see +3 right here. This was subtract 3. That has a 4. It's got the 3 in the wrong place. So answer to this one is B. If the graph of x squared gets shifted 4 units right and 6 units down, which equation would represent? All right, I got to remember 4 units right. That's a number on the inside, but it always inside goes opposite. Okay, 4 units right, 1, 2, 3, 4. That would actually be +4. But when it goes inside as opposite, so it'd be -4. Got that part. Then it says 6 units down. Okay, 6 units down. That would actually mean that I'm going to go 1, 2, 3, 4, 5, -6, because that would be 6 units down. And that's a number on the outside, and that's actually going to be the same as, so that's actually going to be -6. So it should be -4, -6, -4, -6 is choice C. Keeping going. Hopefully it's making good for you. Make a mapping diagram for these. And this is just simply relations of numbers. -3 is related to 1. 0 is related to 6. 3 is related to 2. And 5 is related to -1. When you do your mapping diagram, they do like to see the numbers in numerical order. If I glance here at letter B, -3 is actually related to 2. That's not what it says. In letter C, -3 is related to 0. That's not what it says. In letter A, -3 is related to 1. That is what it says. Letter D just says -3 is related to 1. Wow. A and D both look good. And I believe if you check them, they're all related to the same number. But this one is the best because these numbers are in numerical order. All right? They're in numerical order. And so my lines just have to go -1 is first because it's the lowest, then 1, then 2, then 6. And therefore the lines may crisscross. And that's the way it should be if you have a correct mapping diagram. Okay. The blank is a set of all the x's. I believe that is domain. Okay. And while the blank is a set of all the y's, I believe that is range. So I need domain first and then range. Okay. Which best represents the domain of the function? Now I want you to notice that this one says less than, less than. This actually means every number between. Remember how we do when x is in the middle, less than, that means between. But is this graph every number between 1 and 6? It's not. This is just a 1, just the 2, just a 3, just a 4, just a 5, and just a 6. If you plotted these points, you would see that this is actually what? 1, 3. Okay, I need the 1. This is actually 2 up 1. I need the 2. This is actually 3 negative 1. I need the 3. This is actually 4 up 2. I need the 4. This is 5 up 0. I need the 5. This is 6 up what? 6. And I need the 6. I just need the 1, the 2, the 3, the 4, and the 5. And the 6. So that makes this one, C, is correct. Is this a function? And the answer is yes. It does pass the vertical line test. Do you remember the vertical line test? Okay. The vertical line test basically says if you draw a line through the function at any point and it only touches once, then it's a function, and this one passes. So the answer to that one is C, and the answer to the question is yes. Okay, what is the domain? Now I want you to notice this time I have a circle, so it's not just a certain number of points. It's going to be the whole place with a circle. And if you check your, the way it looks, I think this one is marked off by 2's. So this one is marked by 2's. So that means that this is not, that's actually 2, then 4, then 6, then 8. So if you look closely, those are marked off by 2's. So it looks like if I'm talking about the domain, that I'm focused on the x's. So that would actually be negative 4. That's going to be what? Positive 4. And because that's a line, that would be every number between negative 4 and positive 4. We'll have negative 4, positive 4, and negative 4, positive 4. But which one is the most correct? Answer? X in the middle, because you're talking about domain. So B is the correct one. Is this a function? No, it fails the vertical line test. It fails it. If you draw a line through it, it touches in 2 places, so that makes it a big no-no. Which best describes the range? When we do range, we're talking about the what? Y's. At least every answer in ABCD does mention Y's. Okay, remember we do lowest to highest, and it looks like this thing comes as high as 2. This arrow tells me that it's actually going to come down from what? It's going to go all the way to negative infinity. Now, the way that I read this is I would say that's a less than symbol, so that says y's are less than or equal to 5. Okay, it doesn't come up at 5, so it's not 5. The answer happens to be 2. It does touch at 2, and it's everything below the 2. The answer to that one is B. Is this a function? Yes, it would pass the vertical line test. Which best represents the domain? The domain. Okay, when you talk about domain, you're talking about the what? The x's. Now, I'm looking at this one. I notice that this one would go to the left. It would come from negative infinity in the x direction, but it looks like it stops right here. Okay, so if I talk about from negative infinity to positive infinity, it'd be negative infinity, x in the middle, left, backwards, backwards. It does touch. It looks like it touches at, and this point is over 5 and up 2. 5 is the x number, y number is 2, and again, that's very helpful. My answer to A, the x number is 5. This is the part that I'm seeing, because usually they ignore the infinity on one side. Everybody good? I hope so. 24. Which best represents the range? Okay, range is from x or y's to y's. So I'm going to actually come across here. It looks like it goes from negative 2 up to positive 2. What letters should be in the middle? Well, all of these have y's in the middle. Okay, I have negative 2 and negative 2 to positive 2. But which one is the correct one? Do you happen to notice that this one on the left, which is the first one, this is negative 2. Oops, sorry. I mean to draw that way. Do you happen to notice that down here at negative 2, which this is actually negative 4, down negative 2, this is the y because we're doing range, that negative 2 is a solid circle. If it's solid, you do use the equals, whether it's greater than or equal to or less than or equal to. So that means negative 2 needs the equals. The other one is open. An open circle has no equals. Okay? So that's why A is more correct than C, which represents the domain. Domain is a set of the what? X's, and they all do have X in the middle. So now I'm going to sign on and say, well, it looks like I go from X negative 4 to this X is what? Positive 4. I think that's 4 comma 2. So it looks like I'm coming from X negative 4 to positive 4. Which one should get the equals? Well, again, it's the one on the left. That is the one that is solid. So negative 4 to positive 4 should get the equals. Not this one, not this one. And the choice between D is correct because it has the equals on that one. And that's where we said solid circles get the equals. Oops. 25. Write the factored form. Factored form means parentheses. That means that this point and this point is very much helpful, and they do have some information. All right, so I'm going to have two possible parentheses, X and X, because that's what factored form is. But remember, when they go inside what? They go inside what? Opposite. They go inside opposite. So what's opposite of negative 3? Well, that would be plus 3. This one's going to go in opposite of positive 2, so that would go in as negative 2. It's also, if I notice, this also happens to turn down. This turns down. What do we need to have to make sure it turns down? We need a negative. Okay, and one more thing. Does this parabola have a number? Is it wider or skinnier than normal? Do you remember how we check that? The easiest way to check that is to do your movement. Remember, it would go, a normal parabola goes over 1 and up what? 1. If it turned down, a normal parabola go over 1 and down 1. Okay, that would be a normal parabola. Over, and I'm only focused on the up. So if I go over 1, it looks like I'm going, all right, look at that again. Looked at the wrong point. This is actually my vertex, which is right in the middle, okay? It's actually on a line that comes down here right in the middle, which actually I'm going to answer 26 right now. It looks like if this is negative, this is 0, and this is negative 1, negative 2, negative 3, it looks like that axis of symmetry actually falls right in the middle between negative 1 and 0. That would be x equals negative half. Now, if you come over, you have to go from halfway across and then down. And actually, and my board's a little bit off, this actually goes over 1 and down 1. So there is no number. So that would be just like a 1, or you just put the negative out front. Okay, that one's a little bit different. Make sure you look carefully. Okay, does this parabola turn up or down? This one turns down because it has a negative. And I'm looking at this one right here. We're focused on this one right here. This equation. So we're not looking at the picture anymore. We're done with that picture. What are the x-intercepts? Okay, the x-intercepts come from the parentheses. So look in your parentheses. But remember, they come out opposite. Imagine splitting and solving. What's x plus 1 solving for 0? First one would be negative 1, or that would be the point negative 1, 0. And the other one would be, if x plus 9 equals 0, the answer would be x equals negative 9, or that's negative 9, 0. Now we do have a graph down here, and I'm going to put those points on there. So negative 1 and negative 9. What are the x-intercepts? Got that part. Multiply this out and convert to standard form. Okay. I'm going to do that. Notice I still have my negative out front. So what I'm going to do is I'm actually going to multiply that part first. So if I do my x times x and my x times 9, I believe I get, remember, I'm not doing anything with the negative at first. The first thing I'm going to do is multiply what's inside. X times x is x squared. Okay. Then I'm going to get 9x. Then I'm going to get 1x. And I'm going to add those to get 10x. Remember, outside and inside make your middle. And then 1 times 9 is going to be 9. Now, if I multiply through a negative, that's going to change the sign of every single number. So the function is actually going to be negative x squared minus 10x minus 9. That would be the correct standard form. What is the y-intercept? The y-intercept is the number at the end, which is your c value. Okay? Y-intercept. So my c value is negative 9. So my answer technically is 0, negative 9. If we go to the graph, over 0 and down 9, right there is my y-intercept. Okay? All right. Complete the square to convert it to vertex form. Okay? Complete the square. So it's asking me to complete the square. We haven't done much like this, but I'm going to walk through it with you. All right. I'm going to actually take some space right here. Okay? I'm going to erase this. Okay? Negative x squared minus 10x minus 9. All right. The part that I'm really going to focus on is this part right here. All right. So I'll pull the minus 9 away. And the first thing I notice is I have a pesky negative in the front. When I complete the square, I didn't have no negative. So I'm going to factor it out of the first part. I'm going to factor it out of only the first 2 parts. So I'm going to pull out that negative, and that's going to give me parentheses. If I divide by negative 1, I'd have positive x squared. Divide the second one, I have positive 10x. Now, here's the tricky part. I'm actually going to complete the square inside the parentheses. What's half of 10? Well, 10 divided by 2 is 5. 5 times 5 is 25. So I actually need to add a 25 inside parentheses. Well, I need you to think about, though, and consider, did I really add 25 to the entire problem, or did I just add it to parentheses? Remember, this is supposed to be negative x squared. This is supposed to be negative 10x, which actually means this would have actually been what? Negative 25. Does everybody understand what I just showed you? I worked inside parentheses, but by doing that, I actually added not positive 25 to the entire problem. Overall, I actually subtracted 25. Okay, so to offset that, I'm going to have to come out here and add 25. Please don't get confused. I did add, but I added in the parentheses. And again, negative times positive merely means I really added a negative. So, going back to my parentheses, keep the negative out front, 2 sets, x and x, plus 5, plus 5. Then these two actually add to be plus 16. So my answer turns out to be negative on the outside, 2 sets of parentheses could be x plus 5, parentheses squared, plus 16. Okay, now that I have this, what is the vertex? Well, the vertex is, this one comes out what? Remember, inside comes out what? Opposite, so that's negative 5. This one comes out the same, which becomes positive positive 16. So I'm going to go negative 5, and I'm going to go positive 16. Okay, I had to erase that because I was negative 5 and up positive. I'm going to be off my graphs. I'm going to do that. It looks like my sketch would be something like that. Okay. Is this a max or a min? Definitely a max. What is the axis of symmetry? My axis of symmetry is actually going to fall right in the middle. Looks like right here at negative 5. Okay. So my answer is x equals negative 5, which actually is 5 units. If you count from this one in, you come from this side in, it's right in the middle. So it's in between negative 9, and it's in between negative 9 and negative 1. Negative 5 is right in the middle. Very good. All right. Penny is dropped from the Washington Monument 555 feet in the air. If it's dropped, that means it has no initial velocity. No initial velocity. So this would actually be filled in with a what? 0. The monument is 555 feet in the air. If I was on top of the Washington Monument when I dropped it, the initial height would be 555. So the equation becomes negative 16t squared. There turns out not to be a middle term. Remember, that term won't really be there because it's 0, plus 555. How long will it take for the penny to hit the... Okay, grab your calculator, type this in very quickly. This is one where we're actually having to provide the answer because this is not multiple choice. Your test will be partly multiple choice and partly short answer like this one where you have to provide the answer, plus 555. So that would be the correct one. So how long does it take the penny to hit the ground? Now real quickly, let's just review. Okay, X's are going to be times. Okay, so it's 1 second, 2 seconds. Y's are heights. So when it hits the ground, what height is that? Okay, that's 0 height. So I'm looking for when Y is 0, or as close to 0 as I can get it. So I'm going to actually use my table. Excuse me, use my table. Let me get my calculator. Here we go. Second table. Okay. It looks like between 5 seconds and 6 seconds, I go from 155 to negative 21. So I'm going to stay at 5. I'm actually going to change my table settings. We'll say start at 5. And I'm going to break it down by 0.1 and see what that shows me. Okay, 5.6. I'm still going down. Ooh, 5.8 to 5.9. I go from 16 to negative 1. Let me break down one more time. This time I'm going to start at 5.8. 5.8. And I'm going to say 0.01. Now let's go back to the table. When do I get as close to the ground as 0 as possible? So it looks like 5.88 or 5.89. I would accept either answer. So 5.89 seconds. Okay, that might be the closest one. Miss Patterson's math class convinced her to be shot out of a cannon last day of class. The opening cannon is 16 feet above the ground. That sounds like it might be my what? Start height. And she is shot up in the air with an initial velocity of 70 feet per second. That's my initial velocity. Those numbers are going to go in my equation. Okay, remember how we said you will not have to worry about gravity? Well, we're going to remember we've used negative 16 for gravity a lot. So we should know that by now, negative 16. T squared plus she shot out of the cannon at 70 feet, so 70. And that's going to have a T on it, plus, and then she was 16 feet of the ground, so it's going to be plus 16. Remember, those numbers have to be in there. How long would Miss Patterson be in the air before she hits the ground? So again, using my table, I'm going to look for what? I'm going to look for Y equal 0, or as close to 0 as I can get. Okay, this is another one of those. Grab your calculators. Y equals, I'm going to actually change my table settings back to 0 and start by ones. And go to my equation, negative 16x squared plus, she's 70 feet per second times x, and she is 16 feet off the ground, plus 16. How long will it take her to hit the ground? Looks like it's going to be between 4 and 5 seconds. I'm going to change my table to say start at 4 seconds, break it down by 0.1s. And when I go back to the table, it looks like about 4.5. So let's break it down again, 4.5, and break it down by 0.01, second table. So by the time I go down, I am very, very, very close to 0 at 4.59 seconds. 4.59 seconds. Sorry, 4.59 seconds. What is her height when she is in the air for 2.5 seconds? I can simply go to my calculator and say, you know what, table, go to 2.5 seconds. And I'm going to change that right now back to 1. But I can tell it to go straight to 2.5. My answer should be what? 91. Guys, I'm not having to calculate anything. I'm able to get all of these answers straight off my calculator by actually just knowing where to look. At what time does she reach her maximum height? Okay. Now, if I just go back up and glance at the numbers, I'm going to go back and change my table to start at 1 or 0. Just looking at the numbers, it looks like I get as high as possibly 92. I'm actually going to look at this one this time. I'm going to be on the ground in 5 seconds. And I'm going to go up as high as 92. So I'm actually going to change my window. Remember, we're back on the ground within 5 seconds. And we go up as high as 92. I'm going to change that to 100. See if there's any way maybe I go above 92. Now, this time I'm not going to look at the table. I'm actually look at the graph. Okay. All right. And if I hit the trace key, and I trace, it goes 91, 91.8, 92, 92.4, 92.5, 92.56, 92.50. It is possible, and that happened in 2.12 seconds. It is possible to do what we call a maximum, and I'm just going to walk you through that. We know the answer is about 2.12 or 2.13 seconds, and it's going to be around 92.5, 92.56. So let's just do what we call the maximum. I'm going to do second calc. Number 4 is the maximum. I'm going to go left 3, 1, 2, 3, and enter. And it says right bound. I'm going to go 1, 2, 3, 4, 5, 6. I'm even going a couple extra just to make sure. Remember, you just have to be on the left-hand side of the place and the right-hand side of the place, and then the calculator can guess for you. And it's going to work, and it says yes. My maximum is actually 2.818 seconds, and it's 92.56. 92.56. So 2.18, actually 2.19 seconds. So 2.19 seconds. And our maximum height was what again? 92.56. Is that right? Let me take another glance. Okay, that is the way to do it. If you wanted to break your table settings down and say, you know what, I want to go to 2 seconds and I want to break it down by 0.1, you're going to come up with those same kind of numbers. Remember that? Okay, 2.2 seconds is 92.56. Very, very close. And if you went ahead and said, you know what, let's go to 2.1. Let's break it down by 0.01. You would get the same answer we just saw. Does everybody see that? 9.2 is 5.6.2. Actually, 2.18 or 2.19 seconds is the same in the table. Okay. I just want you to see that there's multiple ways. Maximum and minimum is left 3, right 6, if you choose to do it that way. Volcano erupted in 1959, shooting lava in the air, modeled by the equation. Find the 2 times when the lava is 1,500 feet high. I am imagining volcano, and it shoots up in the air, okay? It shoots up in the air, and it comes back down. If we can imagine 1,500 feet high, okay, this lava is going to climb. It's going to reach the 1,500 mark, then it's going to go high, then it's going to come back through the 1,500 mark 2 different times. Now I want to model this with my calculator, and then I'm going to do it even says a hint, put 1,500 in Y2. So basically I'm actually going to do negative 16t squared plus 350t, and then I'm going to say, that equals the height. But the height I'm most interested in is what? I'm interested in 1,500 feet. So if we can actually put one equation in Y1 and one equation in Y2, I mean, it doesn't really matter which one you put where. We can actually do intersection and find the answer. So I'm actually going to type it in first. So clear, negative 16x squared plus 350x, okay? And my other answer is 1,500. Now, I'm just going to look at my table because it gives me some good ideas. I need to change it back to start at 0 and change by 1s. That's at least going to give me the big picture. All right, I'm going to ignore Y2 because everything's 1,500. But this thing goes 1,500. It's going to be around 6 seconds. And then it goes high, and it's coming back down. So it's about 15 seconds, about 16 seconds. I'm going to say 6 and 16 seconds. Looks like this lava is back on the ground within 22 seconds. And it looks like it gets as high as what? Above 1,500. I'm going to change my window. This thing's back on the ground. It took it 20-some seconds because the volcanoes can shoot that really, really high. So in 20, I'm going to put 22 just to give myself extra. And I'm just going to say 0 to 2,000. Give yourself plenty of extra space up there so you can see a picture. So this models the volcano. I just played with the numbers. I kind of gave myself a little extra space. So now I can actually go trace. I'm going to trace. This one goes to the left. Remember when we looked in the table, it looks like it's 6 and 16. So if I do second trace and I do intersect, okay, and enter, 5.85. Pretty close to 6, 5.85. And the other one, trace, go to the other side. Remember, it gets closer to one side than the other. That looks good. Second calc, number 5 a second time. Enter, 16.02. Pretty good, pretty good. So the answer is the time. Let me use T for time. The first time was 5.85 seconds. And the second time turned out to be 16.102 seconds. So that is my 2 times. All right, and again, I use my calculator model. Number 37, trying to get to the end. This is a long review, but if you do it, I promise you, you're gonna see rewards because you will absolutely be ready for the test. X squared minus 40x plus 610. Okay, oops, I won't go back up. X squared plus minus 40x. Forgot my number a while ago, didn't get it. 610 plus 610. Everything looks good. Taco stand, she has found that the daily costs are approximated by the following. So we have a cost equation. X units of tacos. Find the number that would minimize her cost. Minimize. That means I'm looking for the lowest number in the table. Okay, let's just make sure we know that. Minimize the cost. Second, let me make sure my table settings. Okay, let's go start at 0. And I do have it in ones. Let's go to look at the table. Okay, minimize. 600, 600, 400, 400, 397, 350, 331, 310, 291, 274, 259, 246. Still minimum. Going smaller, going smaller. Oops, oops, oops. So what happened? At 19, I was 211 units of tacos. At 20, I was 210. So it looks like 210 is my cost. 20 is the unit of tacos. I'm going to say at 20 tacos, 20 X's. So at 20 units of tacos, I've minimized my cost. So remember, X units of tacos. So in the X column, down at 20, that was where I had my minimum of 210. So that was the minimum. And so that means that my answer is what? 20 units of tacos. All right, down to the last 2. Did I skip anything? No, 38, 39. Okay. Draw the function. This right here is a number on the outside, so that's going to make it go up or down, same as the number. Okay. So this thing's going to go up 4. 1, 2, 3, 4. The number on the inside makes it go left or right, but it goes left or right what? Opposite. Okay. So this thing's actually going to go not to positive 1, it's going to go backwards to negative 1. So my vertex should be right there. Okay, I shouldn't have put a mark. If you were trying to remember vertex form, this comes out opposite, so it's negative 1. This comes out same, so it's positive 4. So negative 1 and up 4. The negative out front tells me that this thing turns what? This thing's going to go down. And then the 2 in the front actually tell me that it's going to happen what? Twice as fast. Remember, what is the normal movement? It's over 1, down 1. So this thing's actually going to get stretched down twice as fast. So I'm actually going to come over 1 and down 2. Over 1 on the other side and down 2. And when I do that, I have a pretty good picture. That was a skinnier parabola, and it went over 1 and down 2 from the start vertex. And I don't know why I had a blank here, so you just do whatever you need to do on the graph. Write the equation of the parabola shown. All right, and it does say in vertex form. So the first thing I want to do is I want to find the vertex. Looks like it goes over 1 and up 2. So that's actually the point 1, 2. So if I remember vertex form, it's y equals, parentheses, x squared. Then there's going to be a number on the inside. So the inside number goes in what? Opposite. So that should be minus 1. The number on the outside should go in what? Same. So this number would be plus 2. So far, so good. Now, let's check this. It does turn down. So if it turns down, it needs a negative out front. Then I'm going to check and see if it goes down faster or slower than normal. Remember, it's supposed to go over 1 and down 1. So this is going to go over 1 and only down. Oops, it doesn't even go down 1. Looks like it only goes down about halfway. So let's check the second number. It should go over 2 and down 4. Remember, 2 squared is 4. This one only goes down, only goes down 2. This is only going down at half the rate of a normal parabola. So the final answer is negative 1/2. Negative because it turns down, half because it is actually wider. So this one is wider than normal. And it has a vertex at 1, 2. Inside number goes in opposite. Last one. Okay, standard form, the number at the end tells me my y-intercept. So my y-intercept is -24, which is 0, -24. This has a positive, and just to be positive, so this thing's going to turn up. That's everything I can get from standard form. If I take this and I pull the 24 away and I complete the square, to get the vertex form, we're going to complete the square, and this will be an easy one to complete the square of. Okay, half it, then square it. Half of 2 is 1. 1 squared is 1. So if I add 1 in the middle, there's no parentheses or anything, I'm going to subtract 1 at the end. This is going to factor into 2 sets of parentheses that are exactly the same. So I'm going to put x, and it's always a half number. 1 times 1 is 1. 1 plus 1 is 2. So it's going to be plus 1. The number at the end actually turns out to be minus 25. Remember the vertex. The vertex is going to be opposite, which is -1, opposite of what's inside. Same, so this is opposite. This is the same. So it's actually -1, -25. The axis of symmetry is always going to be wherever the x part is. Okay. Also, axis of symmetry, just to review, if you have standard form like this, okay, standard form, the axis of symmetry can be x equals opposite of b over 2a. Okay. If you go out here, a turns out to be 1. Okay, right, that's like a 1. B turns out to be 2. So opposite of b is opposite of 2, which is -2, and then 2 times 1, which would be -1. Notice that that's the same thing as the x coordinate of your vertex, because your vertex is on the axis of symmetry. So it's x equals -1. So it's 2 ways to think of it. Now, if I take this first equation, x squared plus 2x minus 24, and I factor it, this does factor. What two numbers multiply to give 24 that subtracts to be 2? Remember, if the last term's negative, you're subtracting. 1 times 24, 2 times 12, 3 times 8, 4 times 6. 4 and 6. So it's 4 and a 6. The bigger number wins the sign. The bigger number is 6, so it's plus 6 minus 4. Now, that is my factored form. Just like this was my vertex form, this is my factored form. That's all I need. Now, if I imagine splitting and solving, my first answer would be 4. Because remember, you set each one equal to 0, so x would be 4, and then x plus 6 will equal what? -6. My vertices are 4, 0, and -6, 0. When you put all of these pieces of information together, starting with this, 0, -24. 0, woo, can't get down that far. I'll just say -24 is down here. That's my point. My axis of symmetry is at -1. -1. Let me get this in here. So -1 is my axis of symmetry. Okay, right beside that. That would be my line right here, my axis of symmetry. Then I'm going to have my vertex is at -1, -25. So -1, -25 would be like right here, next door, right on this line. There you are. And then it says my zeros are +4 and -6. Okay, and again, I believe that that is in 5 units and over 5 units. So again, that is actually in the middle. If I draw this, my vertex comes down way down here, turns, goes back up, and that would be, that's the best you can draw it, being as I don't have a graph that goes deeply enough. This is a complete study guide. Again, probably has way more problems than you will see on your test. But if you successfully complete this study guide, I feel you will be very well prepared for the test tomorrow.